The power rule is really nice, and it makes the process of finding a lot of derivatives much, much easier. But it only works if your function looks like y equals x to the nth power. So there's a few functions that we need some exponent rules in order to rewrite so that we can use the power rule. So the first one, if you have a power of x in the denominator, if you have 1 over x to the nth, I can rewrite that function as x raised to the negative n power. And once you've rewritten it in this way, then you can go ahead and use your power rule. Similarly with the bth root of x to the a, if I'm working with a root function, I can take that and rewrite that as x to the a over b power, and then after that, it's written in a way that I can use the power rule. So these two exponent rules are going to really come in handy because it allows us to use the power rule in more cases. One thing that I want to make a note of, and I'll mention this multiple times as I'm working through some examples, is that these are not actually derivatives themselves. We're just rewriting them so that we can use the power rule. So it's a really common mistake that I'll see a student, maybe you rewrite 1 over x to the n as x to the negative n, and then say that that's their answer. That's the derivative. Well, no, you've taken the right first step. We've rewritten this, but we still haven't multiplied by our power and then subtracted 1 from the power. Until we do those two things, we haven't actually found the derivative. So this is just kind of one extra step we need to do ahead of the power rule so that we can utilize it in more cases. So we're going to find 3 derivatives here. We're going to find f prime of x first for the function f of x equals 1 over x. So this is really 1 over x, and there's not an exponent written there, but if I wanted to write one, it says 1 over x to the first power. As this is currently written, while this x lives in the denominator, I cannot take the derivative of this function. So I need to rewrite that using this first exponent rule. I'm going to take that x to the first power, and I'm going to bring that up to the numerator. So I'm going to rewrite this as x to the negative 1 power. So when bringing that power of x up to the numerator, it changes the sign on the exponent. So notice here, this is still equal to f of x. I've said throughout this whole thing, I've said, well, f of x is equal to 1 over x is equal to 1 over x is equal to x to the negative 1. So this is still the function. I haven't actually yet taken the derivative. So when I go to take the derivative of this function, f prime of x, we can go ahead and use our power rule now. So I'm going to start by multiplying by my power, negative 1, times x, and then subtract 1 from my power. Be very careful here as we're working with a negative number, so my new power should be negative 2. So you could leave your answer like this, or you could write it as negative x to the negative 2 power. If you wanted to leave your answer like that, yes, that's correct. But later on, as we progress through this course, we're going to be doing more with derivatives. We're not only going to find derivatives, but then we're going to be working with them after the fact. And a lot of us don't have very much experience working with negative exponents. I personally think they're pretty tricky to work with. So I usually prefer to rewrite this with a positive power. I would take this function and rewrite it once again using this first exponent rule. I would rewrite that as negative 1 over x squared. You don't necessarily need to take that step. I would say either one of these answers is correct. But later on in the course, once we start to work a little bit more with derivatives, I think that this is much easier to work with than working with a negative exponent. So I'll usually take that extra step to rewrite things with a positive exponent. But if you really want to leave something with a negative exponent, that's fine. You'll still get full credit on that problem. So next up, we've got a root function this time around. We want to find y prime for the function y equals the cubed root of t squared. So here, I have a different variable t, but the process for finding a derivative is still going to be exactly the same. I'm still going to use my power rule, but in order for me to do that, I need to use this second exponent rule this time. I need to rewrite this so that it looks like x, or in this case t, raised to some power. So in using that second exponent rule, I'm going to rewrite that as t raised to the, my numerator is actually the same as the power on the inside of that radical. So this is going to be t to the 2 divided by, and then that denominator, that's that little number in front of the root. That's called the index of the root. So this time my denominator will be 3. So I'm going to take a moment to rewrite this as t raised to the 2/3 power. But again, at this point, I haven't taken the derivative. I haven't used my power rule. So I still need to do that. So y prime, I'm going to multiply by my power, 2/3 times t, and then I'll subtract 1 for my power. So if you need to do that off to the side, 2/3 minus 1 over 1, well, that 1 over 1, well, that's the same as 3 over 3. When I subtract those two, I would end up with negative 1 over 3. So that is my new power, t raised to the negative 1 over 3. There's my derivative. Now you could leave your answer like this again, but I just said last time I don't really like working with negative exponents. You could say that, or we could say 2 over 3 times 1 over t to the 1/3, but I think that still kind of looks a little bit ugly as well. So maybe I'll multiply those two fractions, say 2 over 3t to the 1/3, and I think that's a lot nicer to work with. So I would say this is a perfectly fine answer, as well as this. I would take either one of those two. If you wanted to go the extra step, you could rewrite this as a root function. In general, I don't think that's really worth it, but if you really, really wanted to, you could also rewrite this as 2 over 3 times the cubed root of t. That would be fine as well, but again, I don't think that step is really worth it, especially if we need to take the derivative multiple times, as we will later on in this course. It's easier to leave it in this form. So there is our derivative. Lastly, part C, we've got this kind of interesting notation here again. This says take the derivative of 1 over the square root of x. So in this case, I actually have 2 of those derivative rules. I'm going to have to use both of them in order to find my derivative. First thing I'd recommend doing is rewriting that radical. So this says take the derivative of 1 over. Now when I rewrite a square root, when we work with something like square root of x, even though there's not an index written there, we're going to go ahead and assume that that is a 2. So when I rewrite the square root of x, that's really x to the 1/2 power. So my denominator is x raised to the 1/2 power. So I've rewritten that radical, which is great, but I still have this power of x in the denominator. I know that I can't take the derivative. I can't use the power rule while I have that x in the denominator. So let's bump that up to the numerator. We'll rewrite that as x to the negative 1/2 power. And now I've written it in the way that I can go ahead and use my power rule. So once I take that derivative, start by multiplying by my power, negative 1/2 x, subtract 1 from my power, negative 1/2 minus, I'm really subtracting 1, which is the same as 2 over 2, so my new power would be negative 3 over 2. Again, you could leave your answer like this if you wanted to. That's perfectly fine. Or if you wanted to rewrite that with a positive exponent, we could rewrite that as negative 1/2 times 1 over x to the positive 3 halves, which is negative 1 over 2x raised to the 3 halves power. Either one of these is perfectly fine for your answer. So I would recommend memorizing these two exponent rules because we are going to be using them quite often in this section and throughout this course. So yes, we do need to have those memorized. And please remember that these exponent rules aren't just the derivatives. They are what allows you to take the derivative. So if you need to rewrite a function of x using one of these two exponent rules, there's really two steps. Rewrite the function first, then use the power rule.